Welcome to Code Sutra. In this video, we will be solving LeetCode problem number 1091, shortest path in a binary matrix. In this problem, we are given a square matrix of size n, that is, we'll be having a n cross n matrix, and we have to move from the starting point, that is 0, 0, to the end point, that is n minus 1, n minus 1. And here we are given two constraints. What are they? Suppose you are at this point. You can move in all the 8 directions. You can move to this point, this. Suppose you are at this point. What are the available options you have? These three. That is, you can move either horizontally, vertically, and diagonally. That is the first problem constraint. What is the second constraint? The second constraint is you cannot go to a position of 1. That is, think of it like a wall. Once you hit a wall, you cannot further travel from it. So, in whichever grid there is 1, you cannot move to that particular point. So, for example, let's take this particular matrix. What is the shortest path from the starting to the ending? It's 4, right? Because we can move from this. Say we had one more 0 here. What is the shortest path? The shortest path would be 3, because we can move to this 0 also, and the shortest path would be 3. So how do we find this out? Let's get into the problem and the approach. See, whenever you have a shortest path problem, the first approach that should come into the mind is breadth first search. Why breadth first search? Because it visits all the available points, all the available positions in the first step, and it will compute all the shortest paths. Then only we go to the next available paths, right? So this is the most intuitive thing to think about breadth first search first whenever it comes to a shortest path problem. So what is the approach that we'll be taking here? Let me explain this. So you are at this point. What are the available options that we have? The available options are this point, and this point. So let's initiate a queue. What does this queue contain? This is the value of I, this is the value of j, and the final one is the value of the distance. So we add 0, 0 and 1 to the queue. We will be using a queue. Why are we using a queue? Because for any BFS problem, we will be using a queue. So what are the available options next? We have this point, and this point, but we will only be adding 0, 1, 2. Why? Because these two are invalid, because they are already ones. And what we will be doing? We will be changing this as 1. Already visited will be changed as 1, because we don't want to revisit those particular positions. So why did 1 become 2? We increase the number of steps. So this is in the queue. Once this is in the queue, we will remove this. Then we will remove this, and we will add the next positions. What are the next positions? We have 2 positions available. That is 0, 2, 3. And what is the next position that is available? 1, 2. And what is the distance? 3. And we can safely remove this particular thing. And we will be changing this to 1 as well. So now we have 0, 2, 3 at this point. What is the valid path? This is the only valid path. So we will be again adding that valid path here. That is 1, 2, but now the distance will be 4, and we can easily remove this and make this 1 as well. So like this, if you go on, finally we will have this point, and if we will check if this is the end point, and if that is the end point, we will just be returning whatever is the distance value. But keep this in mind, we are modifying the original array only in this particular problem. If you do this in any particular interview, you will be rejected. It is not advisable to modify the original array. We are doing only for the sake of this problem. We should never modify the given array. If you are modifying this in any interview, there are high chances you will be rejected. We are checking the first point. Suppose if this is only 1, what will be our answer? It will be -1, right? Because we cannot travel. The first is only wall. And what if this is 1? So that is the first check that we are doing. Then we are computing what are the directions that we can go in the x-axis. Say we can go -1, we can go +1, and we can also say in the same axis. Similarly, it goes for the y-axis. You can also form a matrix here for the direction, but I would prefer this approach since this takes less space. And what is the next thing we are doing is we will initiate a queue, and we will add the first point here. That is, as we discussed, we will add this, and what is the distance it will take, or the number of steps? It will be 1. So we will be changing it to 1, and we will be adding this particular point to the queue. So now we will iterate through the queue, and we will generate all the possible 8 options here. In this particular example, if you see here, from I is equal to 0 to 3 and j. What are we doing here? We are iterating over this value and computing all the 8 values. If you see here, all the 9 values are computed, but it doesn't cause a problem. Why? Because we have already changed that particular value to minus 1. So it won't matter. So what do we do? Until the queue is not empty, we will be doing this. That is, we will be removing whatever is there at the top of the queue, and we will be adding all the next available positions if they are not ones. So that is what we are doing, and we are increasing the number of steps by 1. Finally, we have a condition, that is, if we are at the end point already, what we will be doing? We will be returning the number of steps. What is this minus 1? If we are not able to visit the final thing, so we'll be marking it as minus 1. Say for example, if there are walls, all walls in between, in that case we'll be coming to this minus 1. Thank you for watching the video. Please do like, share and subscribe.